Okay, we're solving exercises of factorization and we're studying methods for factoring. Right now we're going to talk about method number 4, which is called perfect square trinomial. The main idea of perfect square trinomial is that you can get a square of a binomial, and that kind of like represents the exercise that you have. So in order to use this method, you need to get square roots on the terms on the edges, and then you're going to multiply them in order to verify if the restrictions are fulfilled. Which are the restrictions? Well, first, that there has to be 3 terms only on the exercise. If your exercise has more than 3 terms, then you cannot use this method. Second restriction is that the midterm has to be the double of the roots of the edges. That means when you multiply the roots, the double of that multiplication has to be the midterm of your exercise. And the last restriction is that none of the edges must be negative. They have to be positive. But the middle term, there is no restriction about the sign of the middle term. It could be positive or it could be negative. There is no problem with that. So let's try to solve some exercises to see how do we use this method. Okay. So exercise number 1. The first part of the method is you get square roots of the edges. So I'm not going to get square root of 6. No, because that's not on the edge. The edges are x squared and 9. So I'm going to get square roots of those, which are x and 3. And I'm going to multiply them. If I multiply those 2 roots, I'm going to get 3x. Okay. Now, the restriction says that the middle term has to be double of this thing. Now, is 3x half of 6? Or is 6 double of 3x? Yes. So I know that the method can be used. So what will be the answer for this exercise? The answer is always going to be the 2 roots that you got with the sign of the middle term. It's always going to be like that. So the 2 roots that you have with the middle sign. And that inside parentheses has to be squared. That will be the answer for the exercise. Pretty simple, right? So let's see another example. Okay, this one has more than 1 letter, but still you can use the method. You get square root of the edges. So square root of 4x squared will be 2x. Square root of 25y squared will be 5y. If I multiply those 2, it should give me 10xy once I multiply those 2 roots. Now the question is 20, not forget about the sign, is 20 the double of the multiplication? Yes or no? Or is this 10xy half of 20? Yes, it is. So I know I can use the method. The method will tell me that the answer is 2x. You copy the sign of the middle term, so in this case will be minus 5y, which is the other root. Both of the roots with the middle sign. And that has to be squared. That will be the answer for this exercise. Next exercise. Okay, we might have fractions in here. So how do we get roots of fractions? Simple, you just get the root of each number individually. You don't worry about the fraction. You just get the roots. The root of m squared is m. Above, the root of 4 will be 2, and that's it. The root of 4n squared will be 2n. If I multiply these things, the answer will be mn. Now, is this half of 2mn? Yes, 2mn is double of the multiplication. So yeah, we're fine. We can use the method. So the answer for this will be m over 2. Or you can put 0.5m, still works. The middle sign, which is plus 2n. And that will be squared. It always has to be squared because there has to be a multiplication. The square tells me that that parenthesis repeats. Yes, so it's still a multiplication, but the same parenthesis. So you can abbreviate it with square. Next exercise. Okay, this one has pure fractions. So how do we do it? Same thing. You get square root of the edges. I get square root of this and I get square root of this. So if I get square root of each individual number, it will be 3 over 2 because square root of 9 is 3, square root of 4 is 2. Then on the other side, I'm going to get square root of 25 is 5, square root of 49 is 7, and square root of u squared is u. If I multiply these 2 things, the answer will be 15 over 14u. The question is this thing half of this one? I have no idea. How do you know? Or is this double of this one? Simple. You either divide 15 or 7 divided by 2 to see if you get if that thing is half. That's one option. Or you can multiply that thing by 2. If you multiply 2 times 15 over 14, does it give you the other one? Does it give you the other one, yes or no? In this case, yes, it gives you the other one. That means you can use the method. And the answer for this exercise will be 3 over 2, the middle sign, which is minus, 5 over 7u. And that was going to be squared. If you notice, the letters are in kind of like the opposite order. This doesn't matter. As long as the process is fulfilled, there is no problem with this. So that will be the answer for this exercise. Now let's do another one. Okay, 9x squared minus 12xy minus 16y squared. Okay, on first sight, you might think, okay, this is the same way. No, remember one of the restrictions. The edges have to be positive. This one has to be positive, and this one has to be positive too. Do you see the problem? There is a problem in here. This is negative. So I cannot use the method. Not only that, if I try to use the method, I'm going to see that I cannot use it. Let's see. If I get the square root of this, it's going to give me 3x. If I get the square root of this, which it should not be possible because a negative, but still, if I get the square root of only the 16, it will be 4y. If I multiply them, it's going to give me 12xy. Now, this is not half of the other one. And this is not double of the previous one. So, no, I cannot use the method. It doesn't work. So, there is no way I can solve this thing with the method. Does that mean the exercise cannot be solved? No, the exercise may be able to be solved. Actually, the answer for this exercise is 3x plus 4y times 3x minus 8y. Now, you're not going to get this answer using this method. For this, you have to use something we call scissors method. So it's not related to this. So technically speaking, you cannot solve this exercise with method number 4. You have to use another method. Okay. So with this last example, we can see when can we use the method and when we cannot use the method. And that's how we work with the exercises that have to do with perfect square trinomial.